Welcome to this lesson on tag-based access control. Using OCI tagging, you can solve the problem of writing policies for many compartments or multiple groups and resources. This saves you from creating the same policies over and over for each compartment or resource. So let's see how tags make it easier to manage access control in your tenancy. OCI tagging allows you to add metadata to resources, which enable you to define keys and values and associate them with resources. As you can see in this example, you can tag resources with a reference to project, the cost center, or even the project phase, such as production or development. And then you can use the tag in the policy statement to control access to resources in OCI. So that is what we call tag-based access control, which provides you with the option to write policies with tags that span compartments, groups, and resources. You can scope access based on the tags which are applied to multiple groups through a single policy statement. And you can also provide access and revoke access for groups by applying or removing tags without changing the original policy. But now the question is, how does it work? In tag-based access control, we add conditions to the policies, along with a set of tag variables used in this condition. And now you can control access based on the tag that exists on the requesting resource, such as group, dynamic group, or compartment, or on the target of the request, such as a resource or a compartment. So let's see how this really works. And we will look at some of the example. So let's say we are applying tag on the requester, meaning whoever is making the request. So in this case, the requester can be group or the users within that group. It can be dynamic group or it can be a compartment and the resources within that compartment. So the variable that we will be using for the group requester will be request.principal.group.tag and provide a tag namespace here and provide a value for a particular tag key definition. And on right hand side, you can see the couple of examples. In our first example, it allows any user to manage instances in HR compartment, where the tag value for the group is set to production. So in this case, any user who belongs to a group that has been tagged with this particular tag namespace, operation, and project as key definition with the value prod. And please remember that tag will always have key value pair, and with namespace you have more structure tagging. So any group that has been tagged with this particular tag value and the user who belongs to that group can manage instances in HR compartment. Similarly, you can do the same thing with the dynamic group. But if you look at the third example, we have applied tags on the compartment. And if the compartment has been tagged with the particular tag value, then all the instances that are member of that particular dynamic group, instance A, and also reside in prod tag compartment can manage objects in the tenancy. So you can start seeing that it helps you to write advanced policies and give you that extra advantage while writing policies, which can span multiple users, resources, and compartments. And it is very easy to manage. Moving ahead, we will look at a couple of examples where tags are applied to target resources, where you can control access based on the value of the tag applied to the resource or to the compartment where the target resource resides in. And you can see the variable that we use is target.resource.tag with the namespace and along with key value pair. And if you see the example, it allows user of group A to manage all the resources in compartment HR only if target resource are tagged with key operation.project and value is set to prod. And if you look at second example where we have tagged target compartment. So this is how we can use the variables when we are applying the access control on the target resource or on the target compartment. Now we will see two examples to see how these variables can be used in real life. In our first example, we have three compartments: project A, project B and project C. For each compartment, there is an admin group setup: A admin, B admin and C admin. And all three admin groups are tagged with employee group namespace and key definition role with the value set to admin. And also each admin has full access over their compartment through the policies. That is, allow group domain 1 A admin to manage all resources in compartment project A. Similarly for B and C. So now what happens if you want to create another compartment? Let's say test compartment. But you do not want to create another group here just for test compartment. But you want all three admin group to have full access to the test compartment. But the people might leave and join this three admin group. And also it will be a painful task to manage a separate group here because you have to constantly make sure that this group are not dynamic. So you will have to make sure to remove and add users as they get added or removed from these three admin groups. So how we can use tag-based access control for this particular problem? You can use tags associated with three admin groups by writing following policy statement. Allow any user to manage all resources in compartment test where request.principal.group.tag with employee group namespace .role is equal to admin, which is our key value pair. So what will this policy do? It will allow all your existing admin group with the tag to have access to the test compartment. And also if there are any new or existing group that you want to tag with this particular tag value in the future will have the access to the test compartment without having to update the policy statement. So this is how it will make it easy to provide or revoke access using the tag value. Now let us look at second example where we have applied tags to the compartment. Consider again we have three compartments A, B and C where each compartment contain two child compartments test and prod, and we have applied resource group.role is equal to test tag to the test compartment in each project. Now suppose you want to give test engineer access to the test compartment across all three projects. We can use the tag associated with the compartment and write the policy which will look like allow group domain A tester to use all resources in tenancy where target resource compartment tag resource group.role is equal to test. With this policy we are allowing group tester to access the resources across all three test compartments. And if at any moment of time you want to revoke access, you just need to update or change the tag value and done. You do not need to update, add or delete any policy statement. So that is the power of tag-based access control. You put tag either on the requesting resource or the target of the request, and then you write a policy accordingly, and that policy give them access. You can scope access based on the tags applied to the resources, groups or compartment. One more important point is that all OCI services support the request principal.compartment, request principal group and target resource compartment tag policy variable. But not all services support target.resource.tag policy variable. You can refer this official documentation to check out the supported services, which is updated time to time. So I hope you found this lesson useful. With this powerful tag-based access control feature, you get additional flexibility to write your advanced policies. Thank you and happy learning. Hello and welcome. In this demo, we will look at a use case to see how we can use tag-based access control to prevent accidental deletion of a compute instances in OCI. We will consider a setup where we have 4 compute instances running in a demo compartment. And suppose one of our VM is running a mission critical application that need to be protected from termination or deletion. For example, if user accidentally deletes a compute instance, prod web VM that is important to our application, it can cause an outage and possibly cause data loss. So we want to make sure that this compute instance cannot be deleted, even if IAM permissions are in place to manage instances in a working compartment. To do this, we can use tag-based access control, where tags are metadata that can be assigned to our cloud resources to help us organize and manage them. They can be used to label resources based on their purpose, environment, owner, or any other criteria that makes sense for our organization. And for this use case, they can be a flag to prevent an instance from being terminated. So let's see how to tag resource and then apply IAM access control. To tag resource, we must first create a tag namespace. For that, we will search tag on the console and select tag namespace under services. Then click create tag namespace. Select the working compartment and provide a name. We will call this namespace as operations and provide a short description. Click create tag namespace and we have created the tag namespace. Under this namespace, we will create a tag key definition. Click operations, click tag key definition, provide tag key as instance type, provide description, and select a list of values. And we will give critical and non-critical as tag values. Critical and non-critical. And then click create tag definition. As you can see, the key definition has been added to the namespace. Now we go back to the compute instance and tag our resources. First we will tag prod web VM as a critical and other VMs as non-critical. We will select the instance and then click on more action and then select add tags. Here I will select operation tag namespace and then select instance. Type as a key and then the value will be critical. This tag will act as a flag to prevent instance from being terminated. Similarly, we will tag other VMs as non-critical. So I go back to the VMs, more action, tags, and then I will mark them as non-critical. Similarly for other 2 instances. Our instances are tagged. Now we can configure IAM policy. We will navigate to identity and security. We will select policy under identity and click edit policy. As you can see, we have a policy for a user which says allow group TechOps to manage instance family in a compartment sandbox. Now we will add a where clause by editing a policy where we say where target dot resource dot tag dot operation dot instance underscore type is equal to non-critical. This policy allows Security Operation Group to manage instances in sandbox compartment only if tag value is non-critical for instance type. Save policy. Finally, we can test the policy. We go back to the compute and click instances. First, I will select a prod web VM and validate the tag. You can see it is critical, and now we will try to terminate it. As expected, we receive a permission error, preventing us from deleting the instance. Let us try with other VMs in the same compartment and see the response. We are able to terminate instance. This means that group can manage instances only if they are tagged as non-critical. So to conclude, this was a simple use case to make you understand the tag-based access control. It is a powerful feature that allows us to protect critical resources. By assigning tags to our resource and configuring IAM policy, we can apply granular access control to OCI cloud resources to assure their availability and reliability. Thank you for your time. Happy learning. Hello and welcome to this lesson on network sources. In this lesson, we will explore how to use network sources for managing access in OCI. So let's get started. Network sources is a mechanism to control access based on originating IP addresses. Think of it like a gatekeeper who allows access to your resources only if the request is from the IP addresses that you have specified. So how does it work? It is a simple two-step process. In our first step, we define IP addresses, where we create a list of IP addresses that we want to allow. And these IP addresses can come from your virtual cloud network, or you can also have public IP addresses. Basically, you are creating a network source object and adding IP addresses to it. And that network source object can have list of IP addresses from both virtual cloud network and public IP. You can create long list of IP addresses, or you can just have a single IP address in your network source. That depends on your needs. Now, after creating a network source with the list of IP addresses that we want to allow, we go to the second step and write a policy. And when we write a policy, we allow group of users to perform action on the resources in compartment or tenancy. But now we will scope down the access by adding additional conditions for network sources, which contains the list of IP addresses we created in step 1. So how do we do that? We use the keyword request.networksource.name in our policy and provide the network source as a parameter. Now this policy will allow group of users to manage resources in your tenancy only if the request is originated from IP addresses that we have specified in this particular network source. So by using this variable in your condition and creating network sources with a list of IP addresses, you are effectively controlling access to your resources. In this way, you can protect your critical resources and give them access from specific locations only. Like you can say only from office location or few trusted public IP addresses or VCNs. So to wrap up, we got to know about network sources and how to control access based on originating IP addresses by adding condition to your access policy. In the next lesson, we have a quick demo to see how to deploy network sources on console. I hope you found this lesson helpful. Thanks for your time. Hello and welcome to this demo on network sources. For this demo, we will consider a scenario where we have a user who is a part of storage admin group and has permission to manage object family in the production compartment. So user can now create or manage buckets in this production compartment. Now suppose we want to add a condition that allows user to create buckets only from his office location. This condition will help to prevent unauthorized bucket creation from external locations and ensure that all bucket related activities are performed from the secure or trusted environment. So by using network sources, we can follow simple two-step process to add this condition. Step 1, we will add public IP address of office to the network source. In step 2, we will update the policy to add a condition that allows access only if the request is originated from IP address listed in the network source. So let's go to the console and deploy this scenario. Right now I have logged in as tenancy admin and I have permissions to manage policies and network sources. And I have already set up a policy that allows storage admin group to manage object family in production compartment. So to deploy our scenario, first we need to create a network source and add a IP address of office location. For that, I will go to main menu, click on identity and security, and then click on network sources. Click on create network source, provide the name, I will call it as office net, and then we have an option to select IP addresses from virtual cloud network or public IP. I will select public IP and enter any random public IP address. This is just for verification to check our access permission. And later we will come back and add my machine's public IP address. And we have created a network source and our step 1 is completed. Now we go to step 2 to update the policy with a condition. For that we go back to the policies, select the policy that I have already written and edit the policy statement. Here I will add the where condition, where request.networksource.name is equal to office net. Click save to apply the changes. Now this policy will allow users of storage admin group to manage object storage in the production compartment only if the request is originated from allowed IP addresses specified in network source office net. And if the request is made from any other IP address, then the action will be denied. To verify this, I'll switch to the window where I have logged in as user of storage admin group. Now I will go ahead and try to create a bucket. I go to storage, click buckets. First select the production compartment and click on create bucket. Keep all default values and just click on create bucket. And we got an authorization error because our request is not originated from the IP address we entered in the network source, that is 1.1.1.1. Now I will switch back to the admin console and update the network source. First I will get my public IP address. I'll just enter what is my public IP, copy my public IP address, go to the console, click on network sources, select our network source office net and click add network. Select public network and provide public IP address. Click update and you can delete the previous address added for verification. Now we can go back to the storage admin user, refresh the page and try to create a bucket again. Again keep all default values and click on create bucket. And now you can see the bucket got created. That means it is allowing access permission from the IP address we entered in our network source. So with this demo, we got to know how to create network sources and add IP addresses from where we want to allow access, and then update our policy with a condition to check whether the request is originating from the IP addresses entered in network source. So I hope you found this feature useful. Thanks for your time. Welcome to this lesson on dynamic groups. Before we dive into dynamic groups, let us quickly recap few important terms to make our understanding easier. Starting with principal. It is the identity of a caller trying to access or operate on a resource. And we have seen this in the earlier lessons of IAM. Next we have user identity in your organization. So it can be any human being who has access to OCI resources. Then we have an instance that represents a unique computer virtual machine host in OCI tenancy. Service in the case of OCI is an application developed and operated by OCI like compute service, networking service, IAM and so on. So basically anything that provides functionality to an end user. And then resources are unit or instances of an entity that are exposed by a service. A resource can be database, load balancer or anything that you create in OCI as a cloud resource. Now we will look at different resource principal types or patterns available before we dive into dynamic groups. So there are infrastructure principle, stack principle or ephemeral principles. And we will look at each of them in detail. Starting with infrastructure principle. The analogy that we will consider here is think of a birth certificate. A birth certificate can be seen as a provisioning of a resource in OCI, like proving its existence as a cloud resource. And the key idea here is that OCI Identity and Access Management Service has a capability that enables instances to be authorized actors. So the instances become principal and they can perform actions on service resources. That is, instances and application running on the instances can actually call or manage other services. Like for example, object storage service. So in OCI, we have this example of instance principle, where instance is acting as an authorized actor or a principal performing certain actions on service resources. Then we have the second pattern, stack principle, where you can think of someone who has a birth certificate and now can get a passport. Here the passport represents the ability to interact with other resources and perform actions. So think of it like having necessary permissions and credentials to travel and take actions within OCI. So the key idea here is that you are protecting one principle on top of another. So you have the birth certificate and then you get a passport. That means a service controls a resource that specifies the intention of the resource. So the good example here in the OCI can be database, who can make a call to the object storage service to keep the backups. And then we have the third one, that is ephemeral principle. Now you can think of like having a temporary badge which is valid just for one day. Like you have a temporary credentials to perform certain actions and that too only for short period of time. The key idea here is of using injected identifiers. So good example in this case can be functions, where we create a functions and provide temporary access to other services. Like for example, giving limited period access to the object storage service. Now after knowing all resource principal patterns, we will go ahead and look at dynamic groups. Now dynamic group enables grouping of all these resource principal as principal actor, similar to user groups. So you can now group different resource principals together and we call it as dynamic group. And then we write policies for dynamic groups. And these policies will permit principal actor to make API calls against the OCI services. For example, instance calling object storage, database calling vault service or functions calling any other service in OCI. So you write a policy which can let specific resource or specific principal make API calls against any other OCI service. But why do we call it as dynamic? Because we create dynamic groups using matching rules. For example, a rule can specify that instances of a particular compartment will be member of this dynamic group. So by doing this, the members can change dynamically. Suppose you launch the instances or you delete the instances in that particular compartment, the membership of this particular group will change accordingly. And we do not have to maintain it manually, like adding or deleting the members as you delete or create instances in that particular compartment. So we will look at few examples to understand matching rules. When you create a dynamic group, we have to set a matching rule to define the members of dynamic group, where you can define all the instances or any instances of that particular compartment by specifying the compartment ID. You can also specify a particular instance ID to be a part of a dynamic group. You can create a dynamic group where you can specify the resource type. In the matching rule, you can define the resource type, for example, dbas, along with the rule to define particular compartment to which that resource can belong. You can also go ahead and give the resource type as functions or certificates that are available in a particular compartment. Now, when you create a dynamic group by specifying the matching rule, then you need to write a policy to provide access to the principal actors of dynamic groups. For example, you can write a policy saying that allow dynamic group, and now you can see the keyword dynamic group and then the domain name and the group name that can manage objects in a tenancy where you are adding additional condition for a particular bucket and in a specific region. So this policy allows all the members of dynamic group to manage object storage buckets in tenancy. Here dynamic group members can be group of instances or it can be certificate authority who want to keep the records in buckets. Similarly, we can write it for database example that we saw earlier, where we are allowing database backup dynamic group to manage objects in a tenancy. And again, we are adding some additional conditions. So in this way, we allow resource principals to make API calls to other OCI services. Remember the workflow: we first create the dynamic group, then we define the membership rule for adding members or principal actors to the dynamic group. And then we write policies to provide access. If you don't write policies, then the dynamic group members or principal actors will not be able to do anything. So I hope you found this lesson useful. See you in the demo where we will see a dynamic group implementation for a use case. Thanks for your time. See you again. Welcome back to the demo on dynamic groups. For this demo, we will consider a scenario that we will deploy on the console to understand dynamic groups. So as you can see in the setup, we have the VCN with the public subnet and a compute instance DG instance 1 associated with that public subnet. And what we want to do is that we want instance to use object storage service and create a bucket in specific compartment. Now remember, this is not human identity doing it. It is an application running on instance calling object storage service and creating a bucket. In this case, instead of application, we will be using OCI CLI option to create a bucket. It is similar to an application running on compute instance. So if you get it right, we want this instance to be a principal actor performing certain tasks on a particular service. And as we know, to manage or access any service in OCI, we need to authorize that identity using policies. So now the question is, how can we make this happen? For that, we need to do two things. First, what we are going to do is we are going to create a dynamic group. And as you can recall from the theory lessons, while creating a dynamic group, we need to have a matching rule. Here we will add a rule to add all the instances of a production compartment as member of a dynamic group. And second, to authorize the members of the dynamic group, we will write a policy giving permission to manage object family in production compartment. Now let's go to the console and deploy this scenario. Now I am on the console, and to save the time, I have already created VCN and compute instance. I'll quickly show you that. For VCN, I go to networking, select VCN, select the production compartment, and see we have VCN-DG created. And then we go to compute and click instances. We have this DG instance 1, and if you check the details, I have used developer image and we have instance associated with public subnet of VCN DG. Now what I will do is I will SSH into this compute instance. For that I will open a Cloud Shell and I will hit a command SSH -I, provide the private key for this compute instance, space OPC at the public IP address of compute instance and hit enter. And you can see now I am into the compute instance. So the first thing I'm going to do here is I'm going to show you how you can authenticate using auth principle. Let's say I want to get my object storage namespace. For that I will hit the command OCI OS NS get. You can see it will take some time and it will return an error, something related to missing configuration. This is because we have not authenticated this instance to perform that action or command. So I'll just change the command by adding authentication for this particular command using instance principle. And when I do that, you will see that it will authenticate using instance principle, and now it is returning me a namespace for the object storage bucket. Now let us try to create a bucket from this instance. And this is a CLI command provided with name and compartment where the bucket need to be created. And also the command need to be authenticated using instance principle. So if I hit enter here, you will see that we got authentication error because right now I have not created any dynamic group, and also I have not written any policy that will permit this instance to perform action on object storage. That means this instance is not authorized to perform any action on object storage service. So we will come back to this command again after configuring dynamic group and policies. For that I go to identity and security, click domains, select production compartment and select our production domain. Under dynamic group, click create dynamic group. Provide the name DG demo, and for matching rule, I will use rule builder, where you can add all or any instances from a particular compartment, where we need to provide compartment OSID and we can also select instance OSID for a particular instance. Click add rule and always reconfirm compartment OSID to check whether you are allowing correct instances to be a member of a dynamic group. Now I click create and we have our dynamic group created, and all the instances of production compartment are member of this dynamic group. Next, we need to authorize dynamic group. For that, I go to policies and click create policy. Name it as DG policy, and I will select production compartment and use manual option. I'll add the policy where this policy is allowing all the members of the dynamic group DG demo to manage object family in production compartment. Click create and our policy is ready. This policy has given permission to all compute instances of production compartment to manage object family. Now let us quickly verify it. So I will bring up the Cloud Shell from here and run this command again. It will take few seconds, and as you can see here, the bucket has been created with the given name, and it gives some metadata saying that bucket has been created. We can verify this on console. I go to storage, click bucket and see that bucket with the name we provided has been created. And if I go to tags, you have this default tag created by giving the information about instance OSID indicating who created this bucket. So with this quick demo, we got to know how to create a dynamic group and then authorize that group using policies. This allows a principal actor, in our case the compute instance, to call the object storage service, or for example a certificate service to access a vault service to store keys. I hope you found this demo useful. Thanks for your time.
In this video, I'm going to discuss the tips and tricks to get maximum out of this course. Well, let's not keep it a secret. Let me go through the tips one by one. The first tip that I have for you is you know yourself. You know how free you are, right? How much time you can dedicate towards learning OCI Architect Associate course. So based on your availability, for example, you might be in a full-time job or you might be in a part-time job. So you know what you're doing. So based on that, carve out a learning plan for yourself. Set a target for yourself that, for example, I want to complete this course in a week or in a month or maybe 15 days, something like that. That is most important. The second tip that I have for you is while going through the lessons, ensure that you are making your own notes, right? So this is going to act as a very important tool when you are revising. The third tip that I have for you is while going through the demos, pay attention to every minute details. If you have got an OCI account or tenancy, then you should also possibly try to replicate what the instructor is showing in the demo, right? There is no replacement for hands-on. So this is a very critical tip. The fourth tip that I have for you is skill checks. Never miss skill checks. At the end of every lesson, we have created some questions that will help you understand how well you understood the topics. And it's a very nice way of reinforcing the concepts learned. So ensure that you are taking the skill checks and you score a good percentage in the skill checks. The fifth tip that I have for you is hands-on. I have already explained the importance of hands-on, right? Having practical knowledge. So log into the OCI console, play around with different services, and in case you have any query, you can use the Ask Your Instructor option that we have in our video courses. So I hope these tips will work like a charm for you. Thank you so much. Welcome to this module on Virtual Cloud Network. So in this module, we are starting the discussion on OCI networking. And one of the key constructs of OCI networking is a virtual cloud network. So I will explain you what a VCN is, what are the components of a VCN, what are the different types of subnets, how routing works in a VCN, and what are the security constructs associated with a virtual cloud network. Towards the end, I will also show you how a public subnet works and how a private subnet is different from that of a public subnet. So let's get started. Hello and welcome to this lesson on CIDR block prefixes. So it's the first lesson that we have in our networking section. So let's first try to understand what is a CIDR block. So for that, what I will do is I'll open up a whiteboard and I will help you understand CIDR blocks or CIDR prefixes. So the very first thing that you might be wondering is what is this CIDR all about? So this CIDR is nothing but it is classless inter-domain routing. So this is basically the full form of CIDR. Now in layman terms, this denotes a range of IP addresses. Range of IP addresses, right? Now, what is the meaning of range? Range means from a particular IP to a particular IP, right? So we can call it basically from IP to last IP. So this CIDR block is nothing but this is a notation. And how does the notation look like? It basically looks like something like this: a.b.c.d/x. So this is nothing but this is an IP address. This is the slash character. And this is basically a decimal number. Now moving forward, let's say I write something like this. Basically, I am writing a range of IP addresses 10.0.0.0 to 10.0.255.255. So what does it denote? It basically denotes a range of IP addresses. Now, another way to write it in terms of CIDR notation is you write this particular IP 10.0.0.0. Then, as we have already discussed, there is a slash character. And after that, there is a decimal number. So here you see that these two octets. Octet basically means 8. So whenever you see this number, this is an octet. This is also an octet. So we have 4 octets here and total. Therefore, we say that in IPv4 total there are 32 bits because each number is an octet. So here you see that the first 2 octets are not changing. So what this means is that we can put 16 over here. So another way of writing 10.0.0.0 to 10.0.255.255 is by straight away writing this CIDR notation. All right. So if this is clear, we will move on to the next discussion, which is how do we determine what is going to be the number of IP addresses in a network. So how do we determine that? So for that, there is a formula. And the formula is 2 to the power. So how many total bits are there? Basically, this is the address length, right? So 2 to the power 32 minus the prefix length. So in this case, the prefix length is /16. So which equals 2 to the power 16. For this particular CIDR notation, we can have 2 to the power 16 IP addresses. Now let's proceed with an example. And I will illustrate further how this works behind the scenes. Let's say this is the CIDR notation. Now I already have discussed that you can basically have, if you specify this CIDR notation, you can write this range as well. Now let's consider this particular 0.0.0. Let's consider this particular IP address. Now another way to write this is using the zeros and ones. You remember few minutes back I mentioned that each of these numbers is actually an octet, which means total there are 32 bits. Now, how does it look like? To help you understand this, you have to understand this basic formula. If you see, this is 1, this is 2, this is 4, this is 8, this is 16, this is 32, this is 64, and this is 128. So the bits that we will write will be actually in the reverse order, but I'll show you how it looks like. In case you want to have 10, so how will you write 10? So now you just see how we can make it 10. We can make it 10. It is 2 plus 8. So this number is 1. So keep it 0. This number is 2. Make it 1. Just turn on the bit. This again keep 0. This number is 8 because we want 2 plus 8. So 2 is already there. Let's make it 1. And then everything else is 0. So another way to write 10 is 0, 0, 0, 0, 1, 0, 1, 0. So this is how it works behind the scenes. Now I'll give you one more example before we actually move on. 192.168.0. Let's say this is the IP address. Now, how do you write it in terms of zeros and ones? How will we write 192? How will we write 168? How will we write 0? And how will we write 2? So remember, this is the key, 2 to the power 0, 1. Again, you have to kind of do the mental calculation. Just to illustrate, I'm writing it one more time. This is 1, this is 2, this is 4, this is 8, 16, 32, 64, and 128. Now, how will you make 192? If you add 128 plus 64, this will make it 192. That means, so you just need to turn on these bits. So that means 2 to the power 7. That means it will be 1. Then 2 to the power 6, which is 64. 1, 1. Then 2 to the power 32 is not required here because 128 plus 64 will make it 192. So 0, 0, and 0, 0, 0, 0. Similarly, for 168, what do you need? For 168, you need 128 plus, if you add 32, it will become 160, and then you need 8. So how is it going to work? 0, 0, 0, and because the fourth one is 8, we have to make it 1. And then 16 is not required. 0. 32, again make it 1. 64 is not required. 0. And then 2 to the power 7, 128, you make it 1. So 128 plus 32 plus 8. Right? So this is how it works. And then 0. 0 is very simple. You don't need anything, right? 0. So 0, 0, 0, 0, 0, 0, 0, 0. And then it is 2. So this one needs to be 1. So 0, 0, 0, 0, 0, 0, 1, 0. Thanks for watching. Let's move on to our deck. Just make a revision of what we actually studied. So this CIDR prefix is basically representing an IP address or a range of IP addresses in the form a.b.c.d/x. And I already discussed about the components. It basically includes a network address and then a network prefix along with the / character. And then there is also a concept of breaking a larger network into a smaller network, which is known as subnetting. And we'll talk more about it in the upcoming sections. But using subnetting, you can divide a larger network or a CIDR prefix into smaller ones. And remember one thing here, if it is /16 and it is /24, if you are presented with two such networks and you are asked which is a larger network. So remember here, small means large. The smaller the number, the larger the network. Because we have seen /16 will give us 2 to the power 16 IP addresses, whereas /24 will give us 2 to the power 32 minus 24, which is 8. So this is a bigger network. /16 is a bigger network as compared to /24. So this is also one thing that you need to understand. And then this is just an example. So if this is the CIDR block, then the first 24 bits are the network address, this one, first 24, and the last 8 bits are the host address. In our example, we have seen this is something that we considered, and /16, right? That means the first 16 bits are the network address, and then this one is for the host addresses, which can be from 0 to 0 to 255.255. All right, so this is how it works. And then there is also an example here. This talks about the range. We have already talked about it. And this is the same notation that I have already explained to you. How can we write 192, which is basically 128 plus 64. And then let's take a case of this particular IP address, 192.168.1.2. So we can write in this format, right? We have already seen it. And then /24 subnet masks basically denotes 255.255.255.0 because it is /24, and this is this particular IP address. The thing is, if you do the logical AND basically means if both this is 1, then only it is 1. If both these are 1s, then it is 1. Even if 1 is 0, the result will be 0. If both are 0, anyways it is going to be 0. So for it to become 1, both has to be 1. So ultimately this number, if you do the logical AND, it will result in 192.168.1.0 network address. So which is nothing but the network address. All right, this denotes 0. This is to the power 0. I hope after going through this lesson, you will be able to understand CIDR blocks in a better way. And I will see you in the next lesson, which is on virtual cloud networks. Thanks for watching. Hello and welcome to this lesson on virtual cloud network, which is also known as VCN. So VCN is one of the core constructs in OCI networking and is the key building block. So let's understand what VCN is. So let me start with a whiteboarding on virtual cloud network. So let's say this is an OCI region. Inside the OCI region, we have a virtual private network that we call as virtual cloud network or VCN. Now, I can give you a layman example. Let's say this is your company premises, right? This is the data center. This is basically where the employees sit. Now, if you all were to attend a meeting together, you all will go to a room or a hall which is basically isolated from noisy areas, right? So let's call this room as the auditorium or the amphitheater, something like that. So same is the case with VCN. VCN is a private network inside the Oracle Cloud Infrastructure region. What are the things that are associated with this VCN? Of course, when you create this VCN, you will need to associate at least one CIDR block. It has to be at least one CIDR block. Now, when it comes to IPv4, you can have up to five CIDR blocks. If you also enable IPv6, then you can again have up to 5 CIDR addresses. So those are the limits. One good thing about this VCN CIDR blocks is that even after you create the CIDR block, let's say you created this as the CIDR block, you can go ahead and resize it. So you can make it /24. Now, what is the condition? Of course, you can have up to 5 IPv4 CIDR blocks, but the condition is those CIDR blocks, for example, CIDR 1, CIDR 2, let's say you have 3. Those CIDR blocks should be non-overlapping. Now, what I will also do is I will also talk about the IP addressing of VCN. What is going to be the allowable size? So let's also talk about it. If this is virtual cloud network, we can create a VCN from /16 to /30. And another thing that you should note here is that be it any CIDR, for example, 192.168.0.0/24. If we consider this as an example, then the first IP is going to be network address. The second IP is going to be the subnet default gateway address. And the last IP is going to be broadcast address. And these IPs are reserved. And when I say reserved, this basically means that you cannot allocate it to the hosts. So the key takeaway from this discussion is the first two and the last IP address is going to be reserved. Now in this CIDR, can you guess what is going to be the first IP? Of course, it's going to be 192.168.0.0. So this is going to be the network address. What is going to be the subnet default gateway address? It is the second IP address, so which means it is going to be 192.168.0.1. So this is the first one. This is the second one. And which is going to be the last or the broadcast address? The last IP is going to be 192.168.0.255. So this one is going to be the broadcast IP. All right. If this is clear, then what we will do is we will move on to the deck and quickly revisit some of the important topics or discussions. So this will serve as a kind of reinforcement. So as we discussed, VCN is nothing, but it's a virtual private network that you can create inside your Oracle Cloud Infrastructure region. Another key takeaway here is that you should understand that in OCI, if there is a region, it can have one availability domain or it can have 3 availability domains. Now, in case it has 3 availability domains, let's say this is AD1, AD2, and AD3. The VCN is going to reside in a single region. So VCN is a regional construct. It will always reside in a single region. But what it can also do is that it can span across multiple availability domains in case of a multi-AD region. So when we create a VCN, it can span multiple availability domains. Then it's basically a software-defined network, right? As I mentioned, it's a virtual private network inside your OCI region. I have already discussed it that you can have one or more CIDR blocks. And basically what I mean by that is you can have up to 5 IPv4 addresses and up to 5 IPv6 addresses, but having at least one CIDR is mandatory. And the best part is you can also change the CIDR blocks even after you create the VCN. Now this diagram represents that a particular VCN can span multiple availability domains in case we have an OCI region with multiple ADs. And again, I am reinforcing, let's say this is region 1, this is region 2. You cannot create a VCN that is going to span multiple regions. This is not possible. Remember, if this is a region, the VCN will always reside within a region, but it can span multiple availability domains. And this is what you see in this image. So in the next slide, I have already mentioned that you can create the VCN from /16 to /30. And we also talked about the reservations. The first two and the last IP is going to be reserved. Just to reinforce, the first one is going to be the network. The second one is going to be the subnet default gateway address. The last one is going to be the broadcast IP. And in case you are planning to use IPv6 prefix, and in case you plan to use an Oracle allocated prefix, then you will receive a /56 prefix. You can also create a VCN with a bring your own IPv6 prefix. So we have two options when it comes to IPv6. You can use an Oracle allocated prefix, or you can also bring your own prefix. All right, with that, we are concluding this lesson on virtual cloud network. I hope you found this lesson useful. Thanks for watching. Hello and welcome to this lesson on VCN components quick overview. In this lesson, we are going to do a 10,000 feet overview of the VCN components, because in the subsequent lessons, we will deal with each of the components in quite a detail. So let's get started. Let me first bring up the whiteboard to help you understand various components. So if I draw VCN in the center, if you consider VCN to be a larger network, for example, it's a /16 network, you can divide the VCN into smaller networks. For example, /24, right, is a smaller network. So /16 can be divided into, let's say, 3/24 addresses. And I can give you an example of that as well. 10.0.0.0/16. Let's say this is the VCN CIDR. Now we can further divide it into 3 ranges: 10.0.1.0/24, 2.0/24, and 10.0.3.0/24.
So we have divided this bigger network into smaller networks. In this case, 3 smaller networks, and these are actually known as subnets. So the first component here is subnet, and we have seen what a subnet is. Subnet is very important because ultimately inside the VCN we will have subnet. Inside the subnet we will have our virtual machine instances. Now, why is this important? Because this subnet is basically an unit of configuration. What it means? It means there are some constructs in VCN like route table. We are going to talk about it. We have another construct which is security list, DHCP option. So these constructs are set on a subnet level. Meaning, if you attach something, let's say if you attach route table to a subnet, it will affect all the VMs that is inside the subnet. And that is what I meant by unit of configuration. Also, one key thing to note here is that there can be 2 types of subnets. One is public subnet and the other one is private subnet. Now at this time, because we are looking at a 10,000 feet overview of the VCN component, I feel that the information that I have provided with respect to subnet is sufficient. Now let's move on to the second component of the VCN. The second component is route table. When you travel in the roads, right? When you go to the market, when you try to go to a school or whatever, to your office, you see that there are different roads. And sometimes there are 3 or 4 roads that actually merge. And then there is an inspector who is standing over here, or something like traffic police. Now, this traffic police controls the traffic, right? Sometimes it might stop the vehicles coming from this road and allow the vehicles to go from this to this road. Now, same is the function of a route table inside a VCN. This route table determines how the traffic is going to flow. In a way, it is also going to define the path for the destination, how the traffic is going to flow. Whenever you create a VCN, there will always be a default route table. Now, we'll discuss more about route tables in the route table lesson. For this lesson, this information is sufficient. The third component that we have is DHCP options. DHCP stands for Dynamic Host Configuration Protocol. So using DHCP options, we can automatically provide configuration information to instances when they boot up. So this is also a very important component. And finally, we have the components that is related to securing the VCN. So there are 2 components here. The first one is security list, and the second component is NSG, Network Security Group. So there are 2 key components when it comes to VCN security. Both security list and network security group, they define which traffic is allowed to come in and which traffic is allowed to go out. There are some differences between these 2, and one of the differences is this security list is associated to a subnet and network security group is associated with a virtual network interface card. As we proceed with the next lessons, we will look at each of these components in detail. So now let's move on to the slide deck. So as you can see here, in this architecture, you have this region. Inside the region, you have this particular VCN, and inside this VCN, you have a public subnet and a private subnet. And on the left-hand side, you see the customer data center having a customer premises equipment. Please don't get worried or carried away with these terms. We are going to have a look at these terms in detail in the upcoming lessons, but I'm just trying to help you visualize what kind of architecture can be created, right? And on the right-hand side, you see the Oracle Services Network, which is object storage. And in the middle, you see different types of gateways. So in OCI, there are different types of gateways when it comes to VCN, depending on the functionality. So you can see three types of gateways here. One is internet gateway, the second is NAT gateway, and the third is service gateway. We'll talk about this in the upcoming lesson. So moving on, we discussed what a subnet is, route tables, DHCP options, gateways, the three types of gateways that you can see, and network security group and security list that basically talks about the security component. So these two are related to security. This is related to routing. This is related to dividing larger network to smaller network. This DHCP options, it's basically related to configuration information. These gateways, and I can give you a very layman example regarding these gateways. Let's say this is your room and this is your market. Now, in order for you to go from your home, one of the rooms, to the market, you need to step out of a gate, right? You're going to the market. So this is the gate. Similarly, this VCN also has different types of gates. If you want to go to the internet, you go to the internet gateway. For instances in the private subnet, for that, we have another special type of gateway, which is known as NAT gateway. And in case you are communicating with Oracle Services Network, services like object storage, then typically you would take help of service gateway. We'll look at each of these options in detail in the upcoming lessons. So to wrap up, I hope you understood the VCN components at a high level. Thank you for watching.